This sort of question, you need to get the diagram down, maybe sketch your in that's a little bit larger, and start drawing on it and seeing what you can use to help work out the each length. Now, the thing you got to realize ultimately is that you have to connect these up here because this equilateral triangle inside the original equilateral triangle, we have information on it. We know that the radius is 1, and so each length of this equilateral triangle is 2. And we can also add that this is 60, 60, and 60. And then remember, we've got this angle here, these angles here as well. Now, when I did this question, I actually then made an assumption which I shouldn't have. I said, okay, this is 90 degrees. But how can I be sure about that? How do I know that that one there is directly above? We need to prove it, really. I got away with it because it is 90 degrees, but strictly speaking, we need to prove it. And this could be done not just by, the theorem you need to use basically is that the radius of the circle and the tangent will meet at 90 degrees. So I can say that that is 90 and that is 90. That's okay, because that's the circle theorem, which I'm not going to, I think you can quote that without proving it. So the tangent and the radius meet at 90 degrees, which means that this is 30. And we could do similar over here. This must be 90 and this must be 90, so that is 30. However, that actually doesn't tell us for sure that that is going to be 60. So we need to do a little bit more again. And I think the way we do this is to split this equilateral triangle into two. So now I've got a triangle here, and I've also got a triangle here. And check it out. They both have a side that is the radius. So they have equal side here. They both have 90 degrees. That will be 90 degrees because I've split an equilateral triangle into two. And they both have this shared side that is the hypotenuse of both triangles. And actually that can be reordered to RHS. I can use the RHS rule of congruency because you could use Pythagoras' theorem to work out the other side of each, and they would be the same. You could then use SSS, but basically you just need to say RHS. And that means they're congruent. So that also means that this angle here, here we go. This angle here is 30, and therefore this angle here is also 30. And if that's the case, then finally this is 60, and this must be 60, which gives me my right angle that I wanted to use, okay? Then I'm okay, but it's only because I've proven that that's all right. Now I'm going to remove this because I think the shading actually then makes it more confusing. And I'm going to get rid of that 60 and this dotted line. There's just a lot of angles going on at the moment. The main thing is that I've got this 90-degree angle here. Okay, 90 degrees here. Let me keep the 30 there. Okay, now, good. This is good. Now, what next? I want to work out this length here. Maybe I call it Z. Now, I can work out that length if I can work out the smaller length, which I'm going to call X, and this longer length here, which I'm going to call Y. Now, the thing is, because of the symmetry of the situation, this length here is also Y, and this one here is X. So if I can focus on this triangle here, which has got a right angle in it, and I know one of the lengths, then I can actually work out X and Y. And I might just draw that triangle slightly larger over, or just away from everything else over here. So 90-degree angle, and I know that this length is 2, and I know both of these angles. I know this is 30 and this is 60. So maybe I just focus on the 30-degree angle. Right, well, I have tan 30, and that is equal to the opposite, which is x, divided by the adjacent. Therefore, x is equal to 2 tan 30. Now, if you know your exact values of trig, tan 30 is 1 over root 3. So x is 2 over root 3. Also, we have y here. So, right, that one is the hypotenuse, remember? So I'll probably use cos. So cos 30 is equal to my adjacent 2 divided by y, which means that y is equal to 2 divided by cos 30. And again, we need to know our exact value of trig. Cos 30 is root 3 over 2. So I'm doing 2 divided by root 3 over 2, which is the same as 2 times 2 over root 3, and I get 4 over root 3. So x is 2 over root 3. Y, which was over here, is also here, was 4 over root 3. So z is going to be those two added together, which gives me 6 over root 3. Now, all the answers don't have a root in the bottom, so I'm going to need to rationalize the denominator times top and bottom by root 3 to give 6 over root 3 divided by 3, and that's going to give 2 root 3. Nicely done.